Hello everyone. Today I am excited to walk you through a project that combines data science, automation, and visualization, a complete pipeline for weather prediction using machine learning. We will explore how we build this system to predict key weather metrics, keep the data regularly updated, and visualize the insights in an accessible dashboard. Over to you, Yusuf.
Now I'll walk you through the problem context and importance. Accurate weather forecasting is vital across multiple industries. In agriculture, it affects planting and harvesting decisions. In transport and logistics, it helps avoid delays and improve safety. Even in event planning, forecasts can influence operational logistics. But here's the challenge. Weather is influenced by a large number of dynamic and interdependent variables. Traditional forecasting methods require heavy infrastructure, whereas machine learning offers a more scalable and adaptive approach using historical data. Our goal was to build an end-to-end ML solution that learns from past weather patterns, predicts future conditions, keeps itself updated, and presents information in a user-friendly way. Over to you, Shahidi.
Okay, let's start with the ML model. We use supervised learning on structured weather data. The data set includes features like temperature, humidity, wind speed, pressure, cloud coverage, and more. These variables are recorded over time and provide the context needed for pattern recognition. We begin with basic processing, handling missing values, converting categorical feature like weather condition using label encoding, scaling numerical values for model efficiency. Show the code here for label encoding scaling. See the code.
We experimented with several models: linear regression, decision trees, and random forest regressors, eventually choosing the one with the best RMSE score for temperature prediction. Currently, the system predicts temperature based on humidity, but it's modular and easily expandable to include more inputs and output types, like predicting rain or classifying weather types. Next comes automation. Instead of manually updating the model with new data every time, we have designed a scheduling mechanism. This part of the system connects to a weather API or data source, ingests fresh weather data every X hours or daily, cleans and stores the data, optionally retrains the model, or updates input features. Tools like Cron, Windows Task Scheduler, or Apache Airflow can handle this. With this, the system becomes self updating, no manual work required. In our project, we have used Windows Task Scheduler. For example, every morning the system can fetch the latest data, process it, and refresh the dashboard or predictions, making it practical for real world use.
Okay. Once we have predictions, we want them to be usable. That's where Superboard comes in. Superboard allows us to build a no-code dashboard that visualizes models, outputs, and trains in a digestible way. On the dashboard, we can display a line chart of predicted versus actual temperature, a bar chart showing humidity levels across time, icon or labels for weather conditions like clear, cloudy, rainy, live updates via scheduled data refreshers. This transforms raw numbers into actionable insights. Users like farmers, logistics managers, or city planners can quickly make informed decisions without looking at a raw dataset or technical outputs. Over to you, Yusuf.
To improve usability, we added a voice interface using Python's speech recognition and PyTTX3 libraries. When the user opens our GUI app, the system asks for the city name using text to speech. The user replies with the voice input, for example, New Delhi. The system processes that voice, recognizes the city, and fetches predictions. The same app also accepts manual input for humidity and then displays predicted temperature. This humanized interaction makes it more accessible, especially for quick checks or users who aren't technically inclined. Over to you, Shaibi.
The dataset powering this system includes column like data time for tracking changes over time, humidity, wind direction, cloud coverage, all contribute to model accuracy. Weather condition categorical labels used for classification. By cleaning and engineering this data, we give the model the context it needs to make reliable predictions. Over to you, Yusuf.
To wrap up, we've built a weather prediction pipeline powered by machine learning. It's automated, voice enabled, and visually interactive. It uses historical data to predict future conditions. and it's modular enough to be extended with more data or more complex models. This type of system could be deployed in your real world settings to assist with critical decision making, all while reducing manual effort and increasing responsiveness. Due to time constraint, we were we lagged behind to create a very fancy front end, but we are successful in making a machine learning model work and give us the successful predictions and successful results. Thanks for watching, and I would request Shahideen to give us a small demo of our project. Please, Shahideen.
Sure. New Delhi. Twenty. 20. Sorry, Yusuf, the voice is not working.
Can you
Let
give
me
the
use it
manual
manually.
inputs to enter humidity? Enter 20%. Yeah, so as you can see, the temperature trends, the humidity versus temperature graphs, the condition count graphs, and the actual versus predicted graphs. So this is what our model is about. So last but not the least, after you get to know that you'll be getting perfect predictions, perfect results about weather forecast, you just need to schedule it so that for every day, for X hours or daily, you'll get the scheduling and you'll get to know about everyday weather forecast. And this is how it is done. Please, Shahideen, show us how it is done.
Kolkata. Kolkata. Mumbai. Mumbai. My timer is for 5 seconds. Mumbai. Mumbai. Okay, so
So thank you, Shahideen, for this demo. And this is how it's done. So thank you so much. And this is it from our side.